Yesterday's lesson covered the scenario where we were trying to find probability where the order of what was happening mattered. And as we talked about, the situations that we're referring to there are situations where either people are or things are put into a particular order, where if the order is changed, it matters, like sitting people in seats, or titles were associated with um, a particular person's designation. In other words, if I had four people and one was a president, vice president, secretary, and treasurer, if I change those titles up, I have a different grouping. Today, and so just to reiterate what we said is a permutation is an arrangement of objects in which order matters. Okay, now what we want to cover today is a situation where the arrangement doesn't matter in terms of the ordering. So that is called a combination. So a combination is an arrangement of objects in which order doesn't matter. And again, its formula is similar to what we saw for permutations. Instead of NPR, it's NCR, and it's N objects available are taken. And as we talked about with permutations, there is no need for you to memorize anything because your calculator will do it. The most important thing is to understand whether your fact pattern is a permutation or a combination. All right? Now, if you think about it for a moment, given the same number of objects to choose from, which will have more options, a permutation or a combination. Hopefully you'll see permutation, because assigning different positions or titles results in more possibilities. So, in other words, to just take a very simple example, if I had 3 students and I wanted to name one president, vice president, and secretary, okay, there's 6 ways to do that. 3 factorial or 3p3. If I just wanted 3 students to be on a committee and there's no titles or anything associated, there's only one way to do that. It's the 3 of them are on a committee. Okay. So a pizza parlor offers 8 toppings, and I want 3 toppings on my pizza. How many different ways can I do that? Well, hopefully you recognize that that's a combination, because it doesn't matter what order the toppings go on. It's just that you want those 3 toppings. Okay? A very common situation. How many different 3-member teams can be chosen from a group of 7 students? 7C3 or 35. Okay? Now, next one. I have a bookshelf that has 5 mysteries and 6 biographies. I'm going to choose 4 sets of books, and 2 must be mystery, so that means 2 must be biographies. What is the probability that both books, 2 are mystery and 2 are biography? Well, the first thing is, since it's a probability question, you know you have a fraction. The denominator of the fraction is the total number of ways something can be chosen. So I have 11 books. It doesn't say anything about the order the books are chosen. Okay? So I'm choosing 4 out of 11. That's the total number of uh, groups of 4 different books I can choose. Now I have 2 different groups. Group 1 is 5 mystery, and I want to choose 2 of those, and I want to choose 2 of the biographies. Since it's and, I need multiplication. So this would be 10 times 15 over 330, which is 150 over 330. Okay? Next is the yearbook editor has to choose 2 of 14 photos to be randomly placed on the first page of the yearbook. You and your best friend are 2 of these photos. What is the probability you are both chosen? Well, there's only one way for you guys to be on the yearbook because it doesn't say anything about where you are on the page, okay? But there are 14 photos of which 2 are being chosen, so you have a 1 out of 91 chance, okay? The bookshelf contains 6 mysteries and 3 biographies. 2 are selected at random. What is the probability they both are mysteries? So there are, I don't write it that big. There are 6 mysteries. 2 of them are being chosen. There's 15 different combinations of those books, and there's 36 combinations of 2 books in total. Okay? The next one, probability that one book is a mystery and the other is a biography. Mystery times biography over the same 36, or 18 over 36. Now, one thing just to demonstrate to you, we kind of did a little bit of this earlier in this unit when we did like choosing socks or choosing marbles. So if you looked at it this way, I could have chosen a mystery and a biography, or a biography or mystery, because the order doesn't matter. Well, if I did that, a mystery is 6/9, and a biography is 3/8, or 18 out of 72. The biography first is 3/9 times 6/8, or 18 out of 72. And when I add those up, I get 36 out of 72, which is the same percentage here. Can you do either one? Yes, you can. Okay? Now, how many different 6-letter arrangements can I get from the word absent? Well, don't be fooled. This is a permutation now. How many different 5-digit numbers can be, so you could have done 6p6 or 6 factorial. How many different 5-digit numbers can be formed from 1, 2, 3, 4, 5? Each one can be done once. Okay, that's again 5 factorial. All right, and then finally, committee. The buzzword committee will tell you right there that it is a combination. 5 members are selected from 9 freshmen and 7 sophomores. How many different committees can I have that are 3 freshmen and 2 sophomores? That's the total number. If I wanted to get the probability of that, I would divide that by 16C5. Okay? So the key point for today's lesson is that we're talking about combinations. Combinations are where the order doesn't matter. If that is something that that's the key thing that you need to remember from today's lesson.